All right, so on number 1 here, we're asked to use the definition of complementary angles. Now, I'm going to put this here. This is a sheet that I'm going to give out on Friday. It's also available on Canvas. But notice right here, definitions, complementary angles. If two angles are complementary, then their measures add to 90, and then it also has the converse. But the first one seems to match here because the hypothesis is if two angles are complementary, and we see that we have two angles that are complementary. So using the law of detachment, I can draw the conclusion. What can I say? Their measures add to 90 degrees. So I'm going to take this idea, their measures add to 90 degrees, apply it to those two angles. And so we could say the measure of angle ABD plus the measure of angle BDC. Notice we've said that their measures add to 90 degrees. That would be my answer to that first problem. Okay, question number 2 uses another definition, this time an angle bisector. An angle bisector is at the bottom of this sheet. Let me put it this way. So we can see here two if-then statements, because the definitions are really, you could write them as a biconditional. If a ray bisects an angle, then, or if a ray divides an angle into two congruent segments, then here we have the bisect. So it seems to match the first one. We have a ray that bisects an angle. Then what does it do? It divides it into two congruent angles. So I know that angle ABC is divided into two congruent angles. So I'm going to specifically name the angles and state that they're congruent. So angle ABD is congruent to angle, and then this one is angle DBC. Number 3, it starts with the statement no reason. That would be our given. We can also see in the picture that HGJ, JGK are linear pairs. So that one's given to us. They want us to use the linear pair postulate. And so we can see the linear pair postulate over here on the right side of the sheet. It says if two angles form a linear pair, then they are supplementary. Here we have two angles that form a linear pair. Therefore, we can conclude that they are supplementary. So I would simply state that angle HGJ and angle JGK are supplementary. That's the conclusion it allows me to draw. And then they want us to use the definition of supplementary angles. So we can find that, and that's about halfway on the sheet. So let me show you here. If two angles are supplementary, then their measures add to 180 degrees. So that's what I'm going to do. I'm going to say the measures of the angles add to 180 degrees. Here's the two angles. We want to say their measures, so I put a measure in front. It says they add, so I put plus, and then the measure of the second angle. It says they add to 180 degrees, so equals 180 degrees. Okay, the next problem says M is the midpoint, and we're using the definition of midpoint. So what is the definition of midpoint? State, sorry, I'm looking at my definitions. That one, I'm not certain that one's on here. Oh, there it is. It is on here. I was wrong. Midpoint of a segment here. If a point is a midpoint, then it divides the segment into two congruent segments. So I know that I have two congruent segments here. So we can look at the picture. Tells me that this is one of the pieces. This is the other piece. They're going to be congruent. So I can state segment LM. Put the segment line above it is congruent to segment MM. So I put the segment line above it to indicate it's a segment that's congruent. Okay, now in the last one, we have an equation AB equals CD. Now we have AB plus BC. So they modified the left side by adding BC. Look at the right side, it was CD, and they've added BC. So all that's happened is I've added the same number to both sides. Well, that's our addition property of equality, or our addition POE. All right, I hope that helps explain the assignment.